Yes, sir.
Can you see the screen?
Yes, sir.
Yes. আচ্ছা আমার কথা কালকে কাদের সাথে ল্যাব আছে? কালকে কাদের সাথে ল্যাব আছে?
স্যার একটু চেক করে জানাচ্ছি।
আচ্ছা ঠিক আছে।
Section A.
Okay, so we'll start our theory class 4709. Today, in the last class, we had just some basic introduction. In the last class, we had some basic introduction to AI and machine learning. Okay, today we'll formally start our class. Okay, unfortunately, online. Acha. Now, before we dive deeper into machine learning and more complex things, okay, first I want you to understand how AI works. Okay, how a artificial intelligence, okay, might work. Okay, I want you to understand through some problems. There are different application areas. I'm going to show you one or two to help you understand how we say an agent. We call it an agent. Okay, how an AI agent might perform its task. Okay, so which application areas? So the one that we are going to focus here is a search problem. Okay. If you have any question, let me know from time to time. Okay. So if you have difficulty hearing, then also let me know. So how an AI agent can solve a search problem? Now, what is a search problem? Search problem means to find a solution automatically without any human intervention. So what it means is that you want to find a solution to the search problem. Not you, the AI agent will find a solution to the search problem without any human intervention. Okay, we are not going to interfere. The AI agent will automatically by itself will try to solve the problem. Okay, now what can be a search problem? For instance, very common is Google Map. Google Map finding route plus. So if I now, for instance, if I just want Google Map to find the route from, let's say, Uttara if you want my Google Map to find a route from Uttara to, let's say, IoT, there can be multiple ways to go from Uttara to IoT. One way will be, let's say, from directly through Abdullahpur, through the overbridge, let's say here it is Tongi, and directly to IoT. That can be one route. So let's say this is Ajampur. From Ajampur, you can go directly. This can be one route, but there are other routes possible. What are those? For instance, you can also move through Kamarpara. So that is another route. So Kamarpara is another route that you can also take. So there are multiple routes that are possible to go from one place to there. Okay. So Google Map has to find the possible routes. Also, which one is the optimal one? The optimal one can be defined by based on either distance or time. They show both. Usually, generally, Google Map actually focus on time more important. The route that has least amount of time, they usually go for that one. Okay. So, but both of them are considered. So this is like a finding solution. So you are asking your Google Map and it is showing you the road without any human intervention. You are not saying that, okay, I want to go through there or there or nothing. We are just going to do it by itself. Okay. Another example can be, for instance, games. Games like, for instance, chess game. Okay. So when you are playing a chess against a computer and AI, what is the most search most, not most, search best move? Okay. When you are playing against AI or computer in a chessboard, so the AI has to find what should be the next move, what is the best move to give. It is not going to give the most randomly, but it needs to find some optimal move. Okay, that this move will let me win this game. Okay, so it is going to find there can be hundreds and thousands of different moves possible. It needs to find the optimal move. So that's like finding a solution. Okay, a problem, you have a problem, you are finding, the AI has to find the solution. Is it clear?
Yes, sir.
Anyone can give any other example? Can you give any other example?
Sir, word, finding a specific word.
You
Food
mean
Panda giving food suggestions.
For autocorrect.
okay, food suggestion. Yes, there are many different possible. There are many different possible foods. They are going to show you some of the best relevant to you. That's also one search problem. If I give you another one, for instance, uh, puzzle solving, puzzle or maze solving. Okay, so for instance, Sudoku. Okay, and AI can actually complete a Sudoku board if it wants. Okay, so you can actually think of it like this way. They can also solve a puzzle, solve a maze. That's another search problem. This kind of search problem also appears in machine learning in many different areas. Okay, so you have to find the optimal or suboptimal solution. Okay, in many machine learning areas, you will find it later, not today, but gradually as you study, you will find many where you have an AI agent automatically tries to find the solution. Okay, so this is also called optimization problem. This is also come again later. Such problem actually often leads to an optimization problem. Okay. Acha. Okay, so I think this is enough. So there are these are different possible search problems. Okay, that an AI agent needs to find a solution for. Okay, so we want to understand how an AI can actually perform this task, okay, or how we can actually make an AI to perform this task. AI is not going to do it by themselves. We have to set up the AI to do it. Okay, so how we can set up that AI? in a way, in such a way that they can actually find solutions. Okay, solve these search problems. Now, this setting up the AI, this is human intervention, but this is when you are creating the AI. But once we do that, then the AI becomes independent. Okay, so this was one of the point. Any questions so far?
No.
Okay, acha. Now, let us try. If you are just listening, try writing, taking some notes as well. Okay, yeah. Then it will be তোমার মাথার মধ্যে জিনিসটা মনে থাকবে। আদারওয়াইজ জাস্ট শুধুমাত্র দেখলে তোমরা কালকে 2 দিন পরে ভুলে যাবে, পরে মনে থাকবে না আসলে কি পড়ানো হয়েছে। Whatever you study every time, always write down. Okay, then আমাদের মাথা আমরা when you write something, okay, in our head this becomes much more like stable. What we listen or what we hear we forgot very quickly. Okay, so try to practice writing anything, whatever you learn. So let's formulate the AI. Okay, let's create our AI. Now, when we are trying to define an AI like this way, we need some terms, I would say terminologies that will appear, and we need to understand this. So let's try to understand these terminologies. Okay. Number 1 is our agent. Okay. Now, agent means an entity. Okay. An entity that is actually that perceives an environment and acts upon it. Okay, so we are going to call it an agent. We are going to call it an AI agent. So an AI agent is nothing but an entity, kind of entity, that perceives an environment and acts upon it. What does it mean? For instance, think of it like a knight in a chess game. I believe most of you at least know some form of chess. A knight in a chess game. So in a certain state of the game, okay, a knight has how many different moves?
2.
4.
4.
Hi, Koda.
8.
8 moves.
8, yeah.
8 moves. A knight has 8 different moves. So depending on its position, it can move 8 different ways. Okay, so it is not always possible to move 8 different ways, because if it is like in the corner situation right now, it cannot move this way. Okay, it cannot go outside the chessboard. So there are some moves that may be invalid for their position. So that's the environment, the position the knight is. Okay, so an agent, okay, it has an environment like a chessboard, a position of a chessboard, and it is going to act upon that. Okay, it's going to make a move. Okay, that's what an agent does. Okay, number 2 is the state. What is the state? State means is the current environment. Current environment of the agent. That is current position. Okay, the chessboard in the current position. Okay, now number 3 is the initial state. Initial state means the earliest position of the agent. Earliest position of the agent before it is actually acting upon the environment. Okay, so earliest position of the agent before search algorithm. Let's start. So that is the initial condition, you can think of it like this. So this is the initial state. So in the initial state, chess is always going to be here. The knight is always going to be here. Another knight is always going to be here. The position is fixed. If you place a rook is always going to be here or here. So the position is fixed. So in the initial state, the agent is in a fixed position. As we move on in the game, the position shifts, the state shifts, state changes based on the moves. But the initial state is something fixed. That's why everything starts. Okay. So this is fixed. So initial state, that's the fixed position. That's it. So that's like you can say equilibrium position. Number 4,
স্যার একটা কোয়েশ্চেন
yes,
স্যার আপনি নাইটের যে এক্সাম্পলটা দিলেন এখানে নাইটটা কি এজেন্ট চেস বোর্ডে
yes, knight is the agent.
ওকে
Our knight is the agent, the AI agent. Okay. Our rook, that's also agent, but a different agent. Okay, each one is individual agents.
ওকে স্যার
Chess is a multi-agent game আর কি। আচ্ছা, now actions. So action means choices that can be made by the agent. Choices that can be made by the agent on that state. আমি খুব স্লোলি আগাচ্ছি যাতে করে সবাই বুঝতে পারো। So actions means in a particular state, the AI agent can have multiple different moves, okay, or multiple different choices. Okay, it cannot actually cannot perform all the different choices. It is going to choose one of them. How it is going to choose one, that's a different issue that comes later, but it has different possible actions. Okay, so depending on the knight, it has possible choice, 8 choice, but these are fixed. It cannot go outside that. So these are the possible actions an agent can make in a particular environment. So if I consider at this position when the knight is, it can go either from here, it can go either here or here or here. So it has 3 moves or 3 actions possible. Although knight can move 8 different ways, but in this current state, it has 3 valid moves. So depending on the state, that's why I said on that state, depending on the state, the possible moves can change, possible actions can change, vary. Now, performing an action will change the state. So once this knight, let's say from here, it moves to at this position, the current state changes. Now the knight is here, so now this is a completely different state of the game. Okay, everything is shifted. So whenever an action is performed, okay, so the state is changed. Okay, now we have a new state. So this is how the game moves. So when you define, like if you try to write an algorithm in Python, okay, we are not going to cover this in lab. We could, but we don't have the time. I focus more on machine learning and Python. So let's say if I want to write a code, so our algorithm would be defined like this way: a state after a state after a state. Once a move is made, a state is changed. So that's how the algorithm would proceed. Next, we have the transition model. Now, the transition model is basically a function. Okay, what is the function? So the function is like performing action A, okay, on a state S. Okay, if I perform a particular action on a particular state, this is going to result in a new state. Okay, and we represent it as a function of R S comma A. Okay, this action, okay, is performed on this state. The resultant will be a new state, let's say S prime. The resultant is going to be a new state. Okay,
So RS এটা হচ্ছে set of result.
yeah, the result. It is the result. Now, how, like, let's say when this state, from this state, I'm going to a new state S prime. This is going to be defined by the transition model. How so? For instance, for a knight, the state change will be one type. For a rook, the state change will be a completely different type, because knight moves in one way, rook moves in a different way. The move is defined by this transition model. Okay, are you following? So I have to define how the state is going to change. So the way it changes is that how this knight is going to move. So it is defined that it can move 2.5 on right side, left side, anyway. So that's the way it has been defined inside the transition model. So for a knight, the transition is going to be like this. For a rook, it can move completely either this way or completely either that way or any other positions, but it cannot move any sideways. So that's the transition model. Whenever a rook moves, whenever an action, the possible action, valid actions by that rook is performed on a current state, it is going to result in a new state. Okay. So for every type of, if I try to get a game of chess, that's very complicated. But every type of chess pieces that you have a different transition model defined. Okay. So, and based on transition models, the scenario changes. Okay. আচ্ছা, any question so far?
এখানে ট্রানজিশন মডেল এন্ড ফাংশন এই দুইটার ডিফারেন্সটা কি?
Transition model মানে function, what does a function does? A function changes something, right?
Yes.
So let's say if I write y is equals to 5x, okay, that means on x, y is 5 times this x. So the function is multiplying 5 with the current value of x. So that's the function, right?
Yes,
So
sir.
similarly, when you have a state x, if it is a chessboard, the output is going to be something. If it is a rook, output is going to be a little bit different, right? Depending on the criteria that is set by the function. So that's the transition model is performed. Transitioning from one state to a different state. Depending on the AI agent, the transition, how the AI agent is going to transition from one state to another, that will be defined here inside. বোঝা যাচ্ছে আমার কথা?
Inside the function.
Inside the function. The function is going to define how one state to another, how the transition is going to be made.
Okay, sir. Yes, বুঝতে পেরেছি।
আচ্ছা। Number 6, state space. Now, state space means it is a set of all states reachable from the initial state by the agent using any sequence of actions. So this is basically means that where the agent, like say from the initial state, in which places, okay, in which other states the agent can go to. Okay. So an agent, let's say, if you consider the, if I consider a chessboard like this way, so if my knight is here, so what are the, from this state, what are the possible state it can go to? Okay, by any sequence of actions, right? So from here, it can go to either this position, or in this position. There are 3 possible positions after one action. But any sequence from here, it can also go from either here or here. So that is the, you can say, in the second iteration, it can, this is another possible space. So if you like it like this way, iteration 1 is I, where I is equals to 1, there are 3 state I is equals to 2, second iteration, these are 2 possible. But এখান থেকেও from this where this is a possible action, 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 this is. So state space represents all the possible states that are reachable by a particular agent. Okay. This is needed to match something later, but it just shows all the possible state that is possible. Okay, all the possible states. Now, think of it like this way. There are so many possible moves a knight can make, so state space becomes too large. Okay, that's why chess game is very complicated. There are many possible states, but there are other applications where there are not that many actually possible states. The possible states can be very limited or constrained. We'll see later some examples after a few minutes. Is it clear? Any question?
স্যার এখানে সিকোয়েন্স অফ অ্যাকশনের ব্যাপারটা প্রপারলি বুঝি নাই।
Sequence of action মানে হচ্ছে from one action to another. Okay, it is taking action from here. Let's say state 1. When it takes an action, it reaches its section মানে হচ্ছে state 2. From state 2, if it makes another action, it goes to state 3. So from here to here, completely two different states. From here to here, completely different states. So it cannot reach here to here directly, but a sequence of actions, S1 can in future go to at this stage. বোঝা যাচ্ছে আমার কথা? But
আচ্ছা
let's say, let me
এস
define, let me আমি একটু বলি. So let's say if I ask you a question, like from this position, like I'm going to write I'm going to ask you a programming code that within 5 moves, can the knight reach a state, let's say 3,7. 3,7 means 3, 7, 8 positionটা. So now you have to check within 5 moves, that means within 5 set of actions from this initial stage, can the knight go from here to here? করতে পারবে? So you have to check all the possible ways it can go, all the possible state you have to consider. Here, here, here. From here, can it go here? From there, all the possible moves. Can it reach that position? বোঝা যাচ্ছে আমার কথা?
বুঝতে পারছি স্যার।
So that's the criteria. So any sequence of action means you take action one after another. Okay. Usually you put a limit. Okay, how far can we go? If we go down this path, where it will go up to after 5 moves, after 10 moves, where the AI agent will reach. So that's the possible states, and this is defined in the state space. Clear?
আন্ডারস্টুড স্যার।
আমার কথা কি বোঝা জিনিসগুলো কি বোঝা যাচ্ছে যা বলছি?
স্যার আমার একটা কোয়েশ্চেন স্যার।
Yes, question.
স্যার আমরা যখন একটা এজেন্টের স্টেট স্পেস সম্পর্কে বের করতে চাচ্ছি, আমরা কি মানে কয়টা ইটারেশনের জন্য আমরা স্টেট স্পেস বের করব? এটা কি জাস্ট একটার জন্য নাকি ইনফিনিট বা যতগুলো পসিবল সবগুলোর জন্য?
It depends on the task at hand. Okay. A little bit later, after some time, you will see, I will show you some algorithm. You will see automatically how many state space you need. It is defined by the algorithm you are following. Okay. Some algorithm will read hundreds of state space, all of them. Some algorithm will need only 5 or 10. It depends on the algorithm. Okay.
ওকে স্যার।
So how large the state space becomes, that becomes like a condition or criteria where I should stop. If the state space becomes very large, that means I need to carve my algorithm in such a way, otherwise state space just explodes. So I have to keep it to a certain stage that our AI can actually work within that boundary. It becomes infinite, that AI will not find a solution. Okay. So we have to define it based on how large the state space is becoming. We have to keep it in mind. That's why it is all the reachable places. So that actually shows us how many actually possible moves the AI agent will have in future. Clear?
ইয়েস স্যার।
আচ্ছা, now number 7.
এখানে যে স্টেট 1 দিয়ে অ্যারো দিয়ে যে 3 লিখছেন, এটা কি ইন্ডিকেট করতেছে? এটাকে আরেকবার একটু বলা যাবে?
আচ্ছা, এখানে 3 কেন লিখলাম ভুলে গেলাম। ও 3 লিখলাম হচ্ছে from this position,
তিনটা স্টেটে রিচ করতে পারবে।
there are only 3 moves it can actually make. কারণ you see the knight moves 2.5 way. Okay, it can move 1, 2, half, left or right. 1, 2, half. Okay, 1, 2, half. Sorry, 1, 1, 2, half, 1, 2. Or also this way, but this is outside the boundary, so it cannot move. So there are 3 possible area it can go, state it can reach. That's why I written here 3. So it can change from a position. The maximum is 8. Out of 8, 3 is valid.
ওকে স্যার, গট ইট।
Achha. Now, goal test. If you don't know chess, it might become a little bit difficult to comprehend this part. Achha. Doesn't matter. Goal test. Now, so you have to fix a test. Okay, a condition check to whether the current state is the goal state. আচ্ছা, now you have to set up a goal. Okay, goal is like you have to define a goal for the AI agent to perform. For instance, for a navigator app like your Google Map, if you define it that I want to go from this place to there, so whenever you reach a destination, the destination is the goal state. Okay, whenever you get close to that destination within certain, it says, okay, I have reached, you have reached your destination. বলে না?
Yes, sir.
Your destination. So that's the goal test. You keep a goal test that, okay, my agent is following this route. So you're moving around, let's say autonomous drive, autonomous vehicle. It is moving through that particular route defined by the navigator app. Whenever it reaches the location where you want to reach, okay, goal test is performed. You check the goal state, okay, I have reached the position. So that's how you define the final state. Okay, you have to check it. Otherwise, what the AI is going to do. So that's the final check of the AI. Acha. Number 8, then comes path cost. Now, you see, where in any search problem, there can be many possible paths. Okay. So there can be many possible paths, many possible solutions. Even a navigator app, there can be many different ways to go from one place to another. So now you have to measure, you have to some kind of numerical value to measure what is the cost associated with the path. So for Google Map, it can be time, it can be distance, okay, depending on whatever the area is. For instance, if you look at chess game, if you can define, okay, if I move to that position, is my will my knight is going to be taken out by the opposition or not? Okay, if it is not taken out, মানে যদি খেয়ে ফেলে কিনা, যদি না খেয়ে ফেলে তাহলে ঠিক আছে. So it is if it is not taken out, that means it is a good move. Okay, you can define like this way. So there should be a path cost. Any path you take, there should be a numerical value to assign that, okay, this path actually numerical value is this. For this path, numerical value is this. Based on this one, you are going to have an optimal solution. So your different path will have different cost. Okay,
নিউমেরিক্যাল
the optimal solution
জাজমেন্ট করার জন্য
is the
মানে সরি এই নিউমেরিক্যাল ভ্যালুটা
best
অ্যাসাইন করতেছি কি জাজ করার জন্য হ্যালো
in terms of optimal solution is going to be the best in terms of path cost. Okay, so let's say one route, route 1, say route 1 takes 20 minutes, route 2 takes 25 minutes. So the Google Map will automatically switch to this one if it finds that, okay, this route is taking lower. So based on this, it gives you the optimal solution. So Google Map actually gives you the optimal solution. So it defines based on all the possible moves, all the possible way you can move, it gives you the optimal one as well. Okay, and this is defined by the path cost. You measure the path cost for every possible way, then define optimal one. হ্যাঁ বলো question.
স্যার নিউমেরিক্যাল ভ্যালুগুলোকে আমরা ডিফাইন করব?
You will define a criteria. Okay, you have to define a criteria. Okay, how we are going to, for this problem, what is the best way to calculate the path cost? Okay, it can be different for different application. So the path cost for, let's say, navigator app, it is different. Path cost for chess app, for chess game, that is going to be completely different. For Sudoku, that has to be different. It depends on what kind of AI is you are actually trying to build. Okay, depending on the AI agent, the path cost will different. So your problem will define this one, but you have to define something based on which the AI agent is going to take the decision. Okay, whether this path is better or that path is better. বুঝে গেছে?
স্যার আমরা ল্যাগ্রাঞ্জিয়ান করার সময় যে পেনাল্টি টার্মটা ইউজ করেছিলাম, পাথ কস্টটা কি সেরকম কিছু একটা?
ল্যাগ্রাঞ্জি ভুলে গেছি, মনে নেই।
আচ্ছা স্যার একটা কোয়েশ্চেন ছিল যদি
হ্যাঁ বলো।
মানে যদি নিউমেরিক্যাল ভ্যালু না হয় মানে কিছু যেগুলা মানে ধরেন একটু প্র্যাকটিক্যাল টাইপের যে নাম্বার আমরা রিডিউস করতে পারি না ওইগুলাকে কিভাবে অ্যাক্সেস
একটু জোরে, একটু জোরে, তোমার কথাটা খুবই আস্তে আসতেছে। নিউমেরিক্যাল ভ্যালু যদি না হয় তাহলে কি বললাম?
আমি বলতে চাচ্ছি যে যদি এরকম প্যারামিটার থাকে যেগুলা সোলি নিউমেরিক্যাল না মানে নাম্বার ডিস্টেন্স টাকা এরকম না তখন কি করা?
You have to have some way to quantify it. Okay, some way to quantify it. Okay, later within next week you will see some example where it is difficult to quantify. So when you cannot quantify it numerically, you have to have some qualitative way. If cannot be quantitative, you have to have some qualitative way, but there has to be a way to judge. Otherwise, how can you say that whether this one is good or that one is good? There has to be some qualitative way. Okay. Measure the performance is one of the key ingredient of any AI agent.
Exactly, like because in chess there is no specific quantity like this rook knight move is more faster or less
Now,
costly.
there are some specific quantity. Otherwise, how the AI agent is going to know which move is going to be better? The quantity, the path cost is defined in terms of future moves. Okay, if I move this way, after 5 next move, my chess game is going to go in my favor or in the opposition favor. We'll see in next class we will see how in chess we can actually define the path cost. We'll define the path cost as well. In chess game, there are ways to define a path cost. Okay. There are always some ways. Any other question?
স্যার একটা কোশ্চেন ছিল স্যার।
হ্যাঁ বলো।
স্যার এই যে রিসেন্টলি স্যার চেস.com এ স্যার এখন নাকি স্যার প্রবাবিলিটি কাউন্ট অ্যাড করছে মানে স্যার কোন পাতে গেলে স্যার রিস্ক কতটুকু স্যার এইটা কি স্যার
আচ্ছা।
আপনি এখন যে উদাহরণটা বললেন এটার সাথে কানেক্টেড স্যার?
হ্যাঁ, some kind of probability is always there. It is taken, the decision is taken, some kind of probability. There are many different paths. It will going to take the optimal one, the best probability, the probability that is higher, that this one is going to make me win. I have not seen the chess.com, but it is something like that, something similar. Okay, any other question? Acha. So let's move on a little bit. So these are all the terminologies that we are going to use from time to time. Okay, so you need to remember these terminologies. These are the terminologies we are going to reuse whenever we talk about an AI agent performing a task. Okay, now to represent these things mathematically or in programming, the best way to do it is using graph data structure. Okay, some of you are familiar with graph data structure, some of you may not be. Now, graph is just like you have array, you have string, graph is another way to represent. Okay, in graph data structure, we usually have a node. Okay. You don't have to understand it fully, just some idea. So
Sir,
we represent everything
sir,
with a
please.
node. হ্যাঁ বলো।
স্যার স্যার কেন গ্রাফ ডাটা স্ট্রাকচারটা ইউজ করতেছি?
হ্যাঁ আমি আসতেছি, বলা শুরু করি, আসতেছি। আচ্ছা, now the graph data structure actually gives you certain benefit. Okay, again, data structure means how we can represent data. Okay, we have different data structure because there are different data required. There are different ways to represent, and some data is suitable. Some kind of data is suitable for particular one. For instance, when you have an array, you have some data type that is better to be represented using an array. So like a collection of numbers. Okay. Then you have a table. Whenever you have something like CSV file, okay, you need something like table because that kind of data, you need a data structure like table to actually represent that kind of data. So that's the data structure you have. Now, for our case, let's say I have position A or state A. From state A to state B, the path cost is 2. For state A to state C, the path cost is 5. B to D, the path cost is 20. C to E, path cost is 7. E to D, path cost is 3. Now look at this way. So everyone is the, let's say, different segment. From A to B, if I go from A to B, let's say this is my initial state. Okay, and this is my goal state. From A, I want to reach D. Now there are different segments within the way. I can move A to B, I can move A to C. Okay. from this point, if I move A to B, the path cost, some numerical value, whether it is time or yeah, whatever it is 2 and 5. So which one is better, B or C? I should move in B or C.
C.
Now, at this
B.
moment, you don't know
B.
future. At this moment, you know B immediately. From A, you can only know B or C, so B looks better. But from B, this is 20, the cost is higher. But from C, then you have to go E, then you have to go D. But overall cost of this path is lower. আচ্ছা, এখানে পরে আসতেছে। But see, what we can actually, when you represent something like this way, A is represent like a node. This A, B, C, D, E, everyone is a node. What does a node data structure, graph data, what does a node represent? Every node represents a state.
State.
Okay. It also represents a parent node. So what is the parent node of C? It is A. What is the parent node of E? It is C. What is the parent node of A? There is no parent node. A is the parent node. So it also show every node have this information inside. What is the current state? What is the parent state? That means what is the parent node of that one? Then what is the cost? Okay. So from one state to another, so from one node to another, what is the cost? From A to C, what is the cost? From C to E, what is the cost? That is actually, so no, not both. From C to E, C node will have the information, what is the cost from going from C to E? It is 7. So it will have this information. The another one is the action. What are the possible ways you can go from C? So there can be another way, E, F, G, okay. Then G to H, then H to D. So from C, you can have two different ways. So that information is also there. So a particular node have this information, its state, its parent node, its cost, its action. So all this information is located inside node. Okay. So when you represent using data structure, these are the information that you need to move an AI agent. Okay. These are the information that you need, right? To define these things, all the things that we have shown earlier, our goal test, path test, everything. So when you have this data structure like this way, a graph data structure, it can hold the information that we need. So that's why this graph data structure is most suitable to represent something. If you represent using an array, can you represent using an array? আমি A যাব, B যাব, C যাব, তাহলে A থেকে C তে যাব. So I will represent A থেকে A to C, then E, then D array. So then I will need another array. What is the cost from A to C? 5, then 7, then 3. Okay. So this is not like a proper way of representing. You have to have some way to connect everything. So after when it comes to represent this kind of data, using node, it is the best. Okay. So graph data structure is a extremely powerful data structure. One of the most powerful, I would say. There are like insane amount of work on graph-based data structure. The application of graph data structure is insane. But we don't need it for now because we are not going to code it, program it for now. So we are not going to need it, but you just try to understand. Okay. Any other
Just
question?
one question in this, how do we represent this data? Because it looks like a flow chart
It's like
type
a
of thing.
structured data type. মনে আছে MATLAB এর structured data type পড়ছিলাম? Structured data type of MATLAB. So any node, so let's say if you have something, an object, a object has some information. Okay, a dot something is equal to this, a dot something is like this. So this kind of information is stored on a particular node. So in MATLAB structured data type is like this. So node graph data structure is also like this way. It stores some information based on this in the node. Any other question?
স্যার তাহলে আমরা এআই এজেন্টকে রিপ্রেজেন্ট করি গ্রাফ ডেটা স্ট্রাকচার দিয়ে।
হ্যাঁ, if you want to do it in programming, you have to use data structure, graph data structure, to write all the codes that you need.
ওকে,
যে জিনিসটা আপনি ফ্লো চার্টে আঁকলেন ওইটা আমরা কোড করবো আর কি, রাইট?
হ্যাঁ, যদি আমরা প্রোগ্রামিং করতে চাইলে এটা আমাকে কোড করতে হলে আমাকে এইভাবে করে কোড করতে হবে আর কি। Any other issue? আচ্ছা, let's move on before you another terminology, frontier. frontier represents the current state. Okay, we are going to see some examples now. Frontier means the current, what we have in the current state. For instance, in this scenario, for A, what is the frontier?
A itself.
B and C is the frontier for A.
Huh?
A cannot see D. Okay. To A, the possible frontier is B and C. Is it clear?
No sir,
Clear না?
মানে ফ্রন্টিয়ার মানে যদি কারেন্ট স্টেট হয় দেন
না না
ফর এ
এর কাছে what is the next distance possible from A, from the perspective of A? What does A can see? From A,
frontier
you can move to either C or B. So that's the
front
frontier of A.
that's action for A.
হ্যাঁ, action. Yeah. Let's see. Current state or not current state. এটা আমি কিভাবে করলে লিখলে জিনিসটা ঠিক হলো না। I should write next possible state from current state. That's the frontier.
How is it different than action? When action is also the possible choices we have, right?
সেম থিং অ্যাকশন হচ্ছে যেটা আমি পারফর্ম করতেছি, ফ্রন্টিয়ার হচ্ছে আমি কি দেখতে পাচ্ছি, জাস্ট টু সে সামথিং, আমি একটু পরে দেখাচ্ছি। সো ইফ ইউ লুক এট সি, ওকে, সো সি দ্য ফ্রন্টিয়ার ইজ ই অর জি, নট এ ইজ ইন দ্য পাস্ট। ওকে, আচ্ছা যাই হোক, নাও লেটস ট্রাই টু গিভ সাম এক্সাম্পল নাও, এক্সাম্পল অফ সাচ প্রবলেম। হ্যাঁ বলো।
এ কি সি এর জন্য একটা অ্যাকশন হইতে পারে?
If your graph is bidirectional, okay, bidirectional means if you move both ways. If it is not bidirectional, then no. If it is unidirectional, that it only goes one way, A to
So-
C. It cannot go in the reverse way.
So
Yeah,
then
but-
A can also be a frontier for C if the graph is bidirectional.
If the graph is bidirectional, it depends on the type of position you are. So for instance, in a chess game, it is bidirectional. But in some other ways, you don't go in the reverse direction. You only go in the forward direction. Okay. Acha. Now let's it is defined by the, you see in the graph structure, it is defined by this hyphen, you see. The graph can be defined as a unidirectional or bidirectional. So this one defines that it only moves A to B. It doesn't move in the opposite way. Okay. If I want to have something like bidirectional, then I would have written like this way. A থেকে B, B থেকে A. This is the sign I would have used. Okay. Acha. Now, acha. So let's say our search problem is finding a path. Finding a path. Now, finding a path. So let's say our initial position, our initial state is A, our goal state is E. Okay, initial state is A, the goal state is E. Okay, how we can actually find the path? Okay, so what can I do? From A, I will move to B. From B, the frontiers are C and D. Okay, then I can choose to check from C. Okay, if I choose to check C, then I have E, and that's the goal state. Okay, if I choose to check D first, D before that, then it goes to F. Okay, I don't have the solution, then I reverse back to C, then go to E. So there are different ways I can take the path. Achha. So based on this, there are some algorithms. Based on this, there are some algorithms. Okay, these are called search algorithms. Okay. What kind of algorithms? The way it is going to check. Okay, so it is like based on this. It is means the agent is going to check or move forward. Am I audible? নেট চলে গেছিল মনে হয়।
ইয়েস স্যার।
আচ্ছা। Okay, can you see the screen?
Yes, sir.
Acha. So the way the AI agent is going to move, based on this, we have some algorithm. The first one, okay. So this is called a stack. A stack is a data. Have you studied a stack? A stack queue in C programming?
স্যার এই স্ট্যাক কি স্ট্যাক ওভারফ্লো এর স্ট্যাক?
This means last in, first out, or LIFO.
Sir, we studied it in 8086.
Try to understand what does it means. Last in, first out. Okay. Remember this one. Remember our finding path problem. This is our finding path problem. Acha. Let's see. Last in, first out, how does it work? So from A, that was my initial state, A. What do I get after next? I get B. Okay. So every move you make, you perform the goal test. Whenever you make a move, you perform the goal test, whether this is the goal state or not. Remember the goal test?
Yes, sir.
Yes,
Yes, sir.
goal test. Okay. You make the goal test that you take the goal test that this is the final state or not. Okay. So you first make a move from A, you go to B, check whether B is the goal state or not. Is it the goal state? No. Okay. Then next from B, what are the possible frontiers? I have either C or D. Okay. Now, which one you are going to check first, C or D?
I guess
বোঝাচ্ছে আমার
C.
কথা?
কস্ট, যেটার কস্ট মিনিমাম।
No. আচ্ছা, from B, either I should check C first or D first. Okay. Now, that's where I have not defined any cost of the path yet. Okay. At this point, we are in the very initial state of the algorithm. There is no path cost. Okay. There is just movement. Okay. The path cost is something we are going to define in more advanced algorithms. Achha. It is the simplest form of algorithm, search algorithm. So here you see the stack way is to approach is to last in, first out. The last one is going to be given preference. So C, D, which one is the last?
D.
D, okay. Then D will come first. I will check D. Is it the solution? No. Then what is the possible way? What is the frontier of D?
F.
ঠিক আছে. Is it the solution? No. Okay. আচ্ছা, before going to F, I have F. At the point I have F, what are the states that are available to me? I have C and F right now, right? Because C was unchecked. and F is the state that we have now. So C and F both are at the frontier at this, you can say. Now, which one is last?
F.
C or F?
F will take
F is
first.
last.
How is C a frontier of D?
আরেকবার বলো, বুঝিনি কোশ্চেনটা।
C কিভাবে D এর ফ্রন্টিয়ার?
সি তো ডি এর না, বি হচ্ছে
Once we are in D,
আচ্ছা, দাঁড়াও বলতেছি। হ্যাঁ, আচ্ছা, so from A to B, A এর frontier is B, B's frontier is C and D. I have two states, C and D. Which one is the last one? D.
D.
So from D, what is the frontier of D? F. So what is the available state right now? C
F.
and F. What is the last one in? F is last one in. So what do you check now? F. Is F the solution? No. Then you go to C. What is the frontier of C? After you are done with F, then you come to C again. What is the frontier of C? E. Then you check, is E is the solution? Yes. বোঝা গেল আমার কথা? আচ্ছা,
স্যার
যদি না
একটা
বোঝা
question
যায়,
একটু
হ্যাঁ,
বললে
আমি
হবে।
দাঁড়াতাম, একটু দাঁড়া, আমি তোমাকে একটা দেখাচ্ছি। এটা হচ্ছে একটা কোর্সের, আমি তোমাকে দেখাচ্ছি, সিমুলেশন দেখাচ্ছি। আই উইল শেয়ার ইট উইথ ইউ। ক্যান ইউ সি দিস স্ক্রিন?
Yes,
Can you
sir.
see this screen?
Yes, sir.
Acha, there is some nice visualization from here. Can you see this one? I'll share it with you. This is from Harvard CS50 course. Okay, the initial problem that I am discussing. This is some of the things will be from here. Just the first portion. So this is the current scenario. Okay, using a stack. This is the stack. Last in, first out. Acha. So I have the frontier, and I have the explore set. So I am starting A. Okay. A is checked. Explore set means I am checking whether A is the goal or not. Gelo. What is the frontier now? B. Are you following? দেখা যাচ্ছে কি?
Yes, sir. Yes, sir.
Yes,
Yes, sir.
আচ্ছা, now the frontier is now currently B. আচ্ছা, from B, okay, is it the goal? No. Okay, explored, it is done. I have explored, it is not the goal. Then what are the frontiers now? C and D.
C and D.
What is the last one?
D.
D. Okay, so I will check first D. Okay, when you check first D, হ্যাঁ বলো।
এখানে মানে আমরা সিআরডি এর মধ্যে লাস্ট ওয়ান কি জাস্ট মানে অ্যালফাবেটিক্যাল অর্ডারের উপর বেস করে ডি কে লাস্ট ওয়ান বলতেছি, মানে আর তো কোনো মেথড
Whichever you do,
Okay.
you can go left or right or left, both the same thing. ডিফারেন্সটা আমি একটু পরে বোঝাচ্ছি, তোমরা আগে এটাকে বুঝে নাও,
Okay.
আমি তারপর ডিফারেন্সটা বোঝাচ্ছি। Okay, I am going from left to right from now. So C and D. C comes first, then D. If I go from right to left, it would be D and C. The both will be the same. আচ্ছা, আমি আসল জিনিসটা বোঝাচ্ছি একটু পরে, একটু ধৈর্য ধরো। So now I have D. I have checked D. Is it the goal? No, it is not the goal. Okay, so from D, so what is the next frontier from D? I have F. So currently in the frontier, what do you have? C and F. What is the last one in? F. Then I will check F. Is it the solution? No. Then what is the remaining one? C. I will check C. Is it the goal? No. What is the next frontier? E. I will check E. Is it the goal? Yes. So I have reached the solution. বোঝা গেছে আমার কথা? Are you following?
স্যার
Yes, sir.
আমরা সি আর ডি এর মধ্যে ডিফারেন্সিয়েট করলাম কিভাবে?
আমরা ডিফারেন্সিয়েট করতেছি না, তারাও আমরা জাস্ট বলতেছি from B position I am saying that C comes first from left to right. If I go C and D, which one is the last one? D is the last one. I am going left to right. আচ্ছা, এটা আরো উদাহরণ আমি দেখাচ্ছি, একটু ধৈর্য ধরো। আচ্ছা, মেইন বিষয়টা হচ্ছে try to understand the way we are moving. If you try to see, we are moving from A, B. When we go to D, we exhaust this past. মানে আমরা যখন একটা সাইডে গেছি, ডিতে যখন গেছি, সবগুলা শুধু ডি আমরা চেক করতেছিলাম, ডি এর সাইডে চেক করছে। এরপরে যদি আরো থাকতো, ইফ উই হ্যাড মোর হেয়ার, উই উড হ্যাভ কমপ্লিট দ্যাট পাথ ফার্স্ট, দেন উই উড হ্যাড কাম ব্যাক ইন দ্য প্রিভিয়াস ওয়ান। আমি তার আরেকটু এখানে দেখাই, খাতায় দেখাই। There are other examples, don't worry. It will be very clear if within a few, after seeing a couple of examples. আচ্ছা, can you see the screen?
স্যার এই এক্সাম্পলে যদি আমরা ই এর উপরে ডি দিতাম তাহলে কি আমরা ডি তেই ফার্স্টে যেতাম?
দাঁড়াও, আমি তোমার কোশ্চেনটা এখনো বুঝিনি। আমি আগে যেটা বলতে চাচ্ছি সেটাকে শেষ করি, দাঁড়াও। See, in a stack, what you are doing, I have A, then I go to B, then comes C and D. Since D comes last, I will check D first, then comes E, then comes F, then comes G. I will check all of this first. After we are done up to the last point that I do not have the goal in this route, then we'll come back to the list, this one, C. Then I'll check E, then H, then I, then P. Okay, this is my goal, let's say. The difference is, you see, when I was moving at this position, the AI agent has to make a choice. Okay, previously there was no contradictory choice, it's just moving forward. But at this point, it has two different routes. The question is, which route the AI is going to take? Okay, so now this algorithm, if I follow the stack rule, the stack rule says the last one will be the first out. So if I consider that D is the last one, because I'm considering that from C is the first one I have, the D is the last one. So I will go to D, then E, again E is the last one, then F, then G. So I will exhaust this path in this way. Then we'll come back to C, then we'll move towards whatever I have in the C1. Okay, একটু ধৈর্য ধরো, আমি পরে আরো এক্সপ্লেন করতেছি, আমাকে পুরোটা শেষ করতে দাও। So this way, so this is, if I write it like this way, what this stack rule is called DFS, or depth first search. Depth first search. Depth means, why I'm going depth? Because it is exhausting, it exhausts one direction, it exhausts one direction before trying another. What does it mean? Whatever the path I took, if there are 4 different paths, not just 2, let's say I have another path here, X, Y, Z, like this. So CDX, so X is the last one. So I will check whatever comes towards X now. I will finish that path, then we'll come to D. I will finish this path, then I will come to C, then come this way. So it will, whatever the path I have in the last, it will first exhaust that one completely. It will check every one of them in that route, then it will come to the previous route, not before that. আচ্ছা, now
মানে স্যার লাস্ট যে পাথটা আমরা নিব স্যার সেখানেই স্যার মানে গোল
হ্যাঁ,
ইয়াটা থাকবে স্যার।
আগে পুরা ওই পার্টটা আমি চেক করব, তারপর আমি আলাদা সলিউশনে আসবো। আমি একসাথে 2 নৌকায় পা দিব না, আমি এক নৌকা দিয়ে ট্রাই করে দেখব, তারপর আমি আরেকটা নৌকায় যাব, কিন্তু একসাথে 2 নৌকায় পা দিয়ে আমি মানে হচ্ছে প্রোগ্রেস করব না। ঠিক আছে,
কিন্তু
জিনিসটা অনেকটা এরকম।
কিন্তু স্যার এই প্রথমে এই 2 নৌকার কোন নৌকাটা সিলেক্ট করব এটা কিভাবে ডিসাইড হয়?
এটাই তো ডিফাইড হচ্ছে, লাস্ট ইন ফার্স্ট আউট। তুমি যদি লেফট টু রাইট চিন্তা করো, লেফট টু রাইট চিন্তা করলে লেফট থেকে রাইট কোনটা আসতেছে? আমার সি আসতেছে, ডি আসতেছে, এক্স আসতেছে। সো হুইচ ওয়ান ইজ দ্য লাস্ট? এক্স ইজ দ্য লাস্ট।
ইয়েস,
আমি
আন্ডারস্টুড।
যদি রাইট টু লেফট চিন্তা করি, হুইচ ওয়ান ইজ দ্য লাস্ট?
সি
এক্স,
লাস্ট।
ডি, সি, সি লাস্ট। সো বেসড অন হোয়াট এভার ইউ চুজ, ইউ হ্যাভ ওয়ান লাস্ট, রাইট? একটা তো লাস্ট আসবে, ইউ এক্সস্ট দ্যাট সোর্স। It is not about which one you are taking, left to right or right to left, doesn't matter. The point is, whatever you are choosing, you exhaust that one first, then you go to the other possible route. বোঝা গেছে আমার কথা?
ইয়েস স্যার।
আচ্ছা, so here depth first search, the search algorithm goes as deep as possible. As deep as possible in the first direction it gets, keeping others for later. So you can have multiple option, 4 option, 5 option, but whenever in DFS algorithm, whenever you go for one option, you exhaust that one, see everything that is there, then you go to the next one. Okay, let's say you have 5 different games to play. You have God of War, you have Witcher, okay, you have God of War, GOW, you have Witcher, okay, and then you have, let's say, Max
Assassin's
Payne.
Creed.
So
RDR 2.
you can say, okay, I am going to check everyone. I will play this one 1 hour, then this one 1 hour, then this one 1 hour, and see which one is I feel more comfortable with. But that's not what DFS does. DFS means you have started God of War, you finish it before checking the other one, whether it is good or bad. বোঝা গেছে আমার কথাটা? এখন বোঝা গেছে? It doesn't matter which one you are taking, which one you are choosing first, doesn't matter. Whatever you choose first, you exhaust that one completely before going to the next one. That's what DFS does. It exhausts one source. Okay. Now, based on luck, if luck favors,
Sir,
then you have your solution. You have your solution quickly. If luck does not favor, that you may have to go for a huge time. It might take huge time for you to find the solution. So based on, if you're like the optimal one is located here, then you are first exhausting this one, then exhausting this one, then you are going for this one. So the solution might take a long time to find. Okay, because you are, whatever the path you are taking, you are exhausting first. So the solution may be found a long way later, depending on which one you are choosing. Okay, so whatever the solution you are finding, it may not be optimal. Okay, হ্যাঁ বলো।
স্যার স্ট্যাকের সাথে ডিএফএস এর সম্পর্কটা কি আসলে এখানে?
ওকে, স্ট্যাক অ্যালগরিদমটাকে বলা হয় ডিএফএস। ওকে, স্ট্যাক যে রুল, স্ট্যাক রুল মিন্স লাস্ট ইন ফার্স্ট আউট। ওকে, stack rule, the rule of stack is last in first out. If you follow this rule, it will be a depth first search. Okay, if you follow the LIFO rule, it will be the depth first search. You will go the entire depth. Okay, the algorithm is called DFS. The search algorithm is called DFS, and the DFS algorithm actually follow the stack rule. Acha. Now, what is the other one? The option one, the second option. The second option is Q. Q means FIFO. First in, first out. Or this one is called FIFO. Acha. Now, what does it mean? So, unlike DFS, if we follow this one, that will be BFS, or breadth first search. So how does it work? Okay, breadth first search means first in, first out. Okay, I have A. From A, where I would go, I go to B. Okay, acha. Check the B. Is it the solution? No. So what do I have in the frontier? C and D. First came কোনটা আছে first এ?
C.
First came C. Okay, check. Is it the solution? No. Then what is the frontier from C? E.
E.
Okay. Now, what do you have? E and D. Which one came first?
D.
D. So
E.
the first came. No.
E.
D was previously stored. I checked C. The next stage from C is E. But when you have D previously stored, the possible one now D and E, but D actually came first. D was already there. So you check D first, then check, is it the solution? No. What is the next? F. So what do you have now? E and F. I mean, এটা লেখছি উল্টা করে, doesn't matter. Or প্রথমে কোনটা আসছে সেটা দেখছি। Now, among E and F, which one came first?
E. E.
So first came E. Check, is it the solution? Okay.
E.
Fine. So your search is complete. So what you are doing, you see, you are like, তোমার এখন দুই নৌকায় পা, তুমি একসাথে দুইটাতে আগাচ্ছ, বোঝা যাচ্ছে কি? So if you look at here in our scenario, how you are moving, I am moving from A to B, then CD, okay, C তে চেক করলাম কোনটা আসলো E তে, then আমি কিন্তু D তে আমি কিন্তু I have not exhausted the path, this one.
স্যার একটা
After
কোশ্চেন
checking
ছিল।
one, I have gone to D, then go on to F, then this, then this. I will parallelly, okay, at the same time, I will follow different routes. I will not exhaust only one route, but I will have my move in both the routes. That's what Q means, or breadth first search means. I will go to all the possible directions at the same time, one after another. হ্যাঁ বলো।
স্যার আচ্ছা, সিডি এর জায়গায় স্যার সাথে স্যার আরেকটা রুট আছে এক্স, তার স্যার এক্স এর থেকে যেটা ইয়া হইছে, মনে করেন এক্স থেকে আরেকটা ওয়াই বের হইছে, তো আমি কি
হ্যাঁ।
প্রথমে হইতেছে স্যার সাপোজ হইতে, হ্যাঁ, তো আমি প্রথমে হচ্ছে সি চেক করলাম, তারপর ডি চেক করবো, তারপর এক্স চেক, মানে এটা রুটটা কিভাবে হবে একটু আমাকে ইয়ে করে দেন তো।
ফার্স্ট সি থেকে ই আসবে, দেন ডি থেকে এফ আসবে, দেন এক্স থেকে ওয়াই আসবে, দেন ইউ উইল চেক ই, দেন এফ, দেন ওয়াই প্যারালালি,
ও আচ্ছা, মানে একটা একটা করে প্রত্যেকটা পাথ থেকে।
একটা একটা করে একসাথে অল। ওকে, সো
তখন
what
সলিউশন
this
কোনটা হবে স্যার? এক্স।
solution হচ্ছে তোমার গোল স্টেট, the goal state is the solution. Okay, it depends on how you are checking. আচ্ছা, so what this is doing, একটু ওয়েট করো, আমি আরো দেখাচ্ছি, আরো কিছু এক্সাম্পল দেখাচ্ছি, তোমাদের জিনিসটা আস্তে আস্তে ক্লিয়ার হয়ে যাবে। Follow multiple directions at the same time. So what we are going to do here, we are going to follow multiple directions at the same time. So difference with the previous one, the DFS is, in DFS you are exhausting one path, then you are moving to another. But here you are taking all the paths simultaneously. Okay. So the problem with this one will require a lot of memory, because you have to keep in mind what all the possible routes, but this one will bring out the optimal solution. Okay. Acha. Now I'm going to show you the visualization now. One thing that we
BFS কি অপটিমাল
self-study.
সলিউশন নিয়ে আসে?
হ্যাঁ,
BFS অপটিমাল সলিউশন নিয়ে আসে ফাস্টার? মানে লাস্ট কথাটা আমি ক্যাচ করিনি আসলে।
BFS will definitely find the optimal solution because it is going parallelly. Since it is going parallelly, it will find the optimal solution first. In DFS, it can be or cannot be. You see, in DFS, if the path it has chosen, the first path is X, then it is going to take a long time for it to find the optimal solution. But if it has chosen C, it would have find the optimal solution in the first way. So it takes time for the DFS to find the solution. It depends on luck. But for BFS, since you are moving all those ways parallelly, there is a
আচ্ছা
better, it will always going to find the optimal solution that, okay, this is the best path.
স্যার
হ্যাঁ, এটা তুমি আরেকটু দেখলে বুঝবে, একটু দাঁড়াও। So this one, pros and cons, this will be your self-study. Okay, what is the advantage of this algorithm and what is the disadvantage of this algorithm? Okay, try to understand this one. হ্যাঁ বলো, কোশ্চেনটা বলো।
আচ্ছা স্যার, ফার্স্ট মেথডে স্যার মানে এটা কি স্যার সি আর ডি যখন চুজ করতেছে, এটা কি কমপ্লিট লাকের উপর চুজ করছি, মানে সিডি আর এক্স? আচ্ছা, ওই যে তিনটা প্যাথ আছে না, তো ফার্স্ট মেথডে যে সি প্রথমে ইনপুট হইছে, দেন ডি ইনপুট হইলো, দেন এক্স ইনপুট হইলো, তাহলে কি আমি এক্স প্রথমে চেক করবো, দেন এক্স এর সব ব্রাঞ্চ চেক করবো, তারপরে স্যার ডি এ আসবো, দেন ডি এর সব ব্রাঞ্চ চেক করবো, এভাবে কি যাবে?
হ্যাঁ, এইভাবে। এখন তুমি এক্স আগে নিচ্ছ না সি আগে নিচ্ছ, দ্যাটস র্যান্ডম, ইটস লাইক এ
আচ্ছা
কয়েন টস, তুমি যেটা নিতে পারো। বাট তুমি যদি সি নাও, তোমার সি এর মধ্যে যতগুলো আছে সবগুলো আগে চেক করতে হবে, দ্যাটস দ্য
আচ্ছা
ডিফারেন্স।
স্যার এটা কি আমার অ্যালগোরিদম চুজ করবে না আমি চুজ করবো?
কোনটা,
যে
সি আগে নিবো না এফ আগে নিবো?
জি স্যার, সি আগে নেবো না এক্স আগে নিবো এটা?
এটা তোমার র্যান্ডম, তুমি অ্যালগোরিদমে ডিফাইন করে দিতে পারো লাইক বেসড অন এ র্যান্ডম প্রবাবিলিটি। ওকে, ইউ হ্যাভ 3 পসিবল পাথ, হুইচ ওয়ান টু টেক ফার্স্ট র্যান্ডমলি, মেক এ কয়েন টস। There has not to be a fixed one, because you see there is, আমাদের কাছে আমাদের পার্সপেক্টিভ থেকে আমরা চিন্তা করতেছি আরে সি এতে সলিউশন আছে সো এখানে, বাট থিঙ্ক অফ ইট ফ্রম দ্য পার্সপেক্টিভ অফ এআই এজেন্ট, ইট ডাজন্ট নো হুইচ রুট হ্যাজ দ্য সলিউশন, সো it sees 3 paths, okay, whichever he wants he move. Okay, বুঝতে পারতেছো? থিঙ্ক অফ ইট ফ্রম দ্য পার্সপেক্টিভ অফ দ্য এআই, not from your perspective যে তুমি দেখছো যে সি পাথেই সলিউশন আছে সো ওই পাশে আমার আগে যাওয়া উচিত কিনা, নো নট দিস ওয়ে। From the AI agent's perspective, all three looks the same from his position. He will choose whichever path he prefers first, it doesn't matter, randomly. Okay? Any question? আচ্ছা আমরা একটু ইয়াগুলো দেখাই কারণ অনেকক্ষণ হয়ে যাচ্ছে, আরো অনেক কিছু বাকি আছে। So if I go for, can you see the screen? If I go for, can you see the screen?
Yes, sir.
Yes, sir.
আচ্ছা। If I go for BFS, now see how the BFS works. I have the frontier A. Okay, explore, done. Then B, then done. Then I have C and D. I'll first go for any one of them. Let's say C. Check করলাম. Then what do you have? E. Okay, then I will first in, first out. So I will check D. Then I have F. Then E will come first. Then check E. E is the solution. This way. So this one goes like this way. আচ্ছা আমি তোমাদের এটা দিয়ে দিব। I will provide you this PDF so you can check by yourself. Let's see another example. This is the better one. Try to understand. This is the interesting part. আচ্ছা, now see, this is a puzzle, okay, or maze solver. I want to go from A to B. Okay, বোঝা যাচ্ছে আমার কথা? So if I move based on depth first search, see how it goes. Okay, this is the black one is the path and the gray ones is blocks. Okay, now here I am in a position. Should I go left or should I go right? কোন দিকে যাব?
Right.
আমরা অ্যাসাইন করব আর কি লিফোতে
রাইট স্যার।
From the perspective of AI agent, both are look same because he doesn't see that our solution bite আছে. You are thinking it from the perspective of a 3D, 3 dimension, but you don't, for the AI perspective, it does not have the third dimension. It is in that position, it sees two paths. I can go either left or right, whichever I want. Now the algorithm defines if it is depth first search, let's say it has taken the left route. So if it is depth first search, it is not now going to exhaust that path. What I say? It is not going to check the other one. It is first going to check all this. Again, it is in a dilemma. I have two routes. I will go any other way. Okay, এই পাশে গেলাম, exhaust করলাম. I don't have the solution. Then I will come back to this one, to this position. Then I'll go to the other path. Okay, যাচ্ছি again. A dilemma, which one? Upper or lower? একটাতে গেলাম. Okay, নাই ওই পাশে. Then come back. Then here, again two different solution. I can go either downwards or rightwards. Now I have gotten rightwards. আমি নিচে যাইনি, okay, from this position. Again গেলাম উপরে, nice solution. আবার নিচে গেলাম. Okay, I have found the solution. So did I explore this path? One path was left unexplored.
Sir,
It depends on the point toss, okay, the probability of finding, not probability, randomness, okay, randomly. But the key point is whichever path it takes, it is going to exhaust that path. That's the depth first search algorithm. হ্যাঁ বলো।
sir, এটা কি universally defined কিছু যে right comes first then left?
No, it is random.
না মানে এটা মানে আমি কি ডিফাইন করতে পারবো যে left comes
Yes,
first?
you can define first. You can define like আমার মুভগুলো সব লেফট, যদি আমি ডিফাইন করি এইভাবে, I will always move left first or I will always move right first. Whatever you can choose, you can define it. It doesn't matter. Left or right doesn't matter. Again, left or right আসতেছে যা কারণ তুমি সলিউশনটা দেখতেছো, but actually from the perspective of AI there is no left and right. It has two solution, it has going to choose one of them. That's it. Okay, আচ্ছা,
Now if
now
it is going to choose one of them, তাইলে আমরা কিভাবে ডিফাইন করব যে লাস্ট ওয়েটাই সে চুজ করছে? মানে আমরা যখন ডিএফএস মানে ডিফাইন করছি তখন তো বলছি যে এটা লাস্টটা আগে চেক করে।
again জিনিসটা বলছো, the thing is last in first out প্রসেসটা হচ্ছে একটা পাথকে এক্সস্ট করে দেওয়া। Last in first out means whatever you choose, that one is going to keep on coming again and again and again, that path. That's what the idea means, last in first out. So from this one, left and right both are the same thing. It doesn't matter which one is last. If you choose this one, it is going to exhaust this one. If it is first in first out, then the algorithm says you have to check simultaneously. That's the difference.
ধরছি স্যার।
Which one is last? It doesn't matter. This one is last, this one is last, that doesn't matter.
বুঝতে পারছি স্যার,
আচ্ছা
থ্যাংক ইউ।
আচ্ছা now from here again, if I go this way, okay, this is one solution, but this solution is not the optimal one. You see, if I go depth first search, if I go this way, it may not find the optimal one. But initially, if it had chosen this way in the randomness, it might have found the optimal path, because this is the shortest path. Shortest path is the optimal one. It might have gotten the shortest path if it is moved this way. So that's in DFS, the optimal solution is by luck. Okay, I might find this one, I may not find that one. That's it. What about breadth first search? Okay, now interesting. I will move both way. একসাথে দুই নৌকায় পা। I will go this one or this one, this one, this one, this one, this one, this one, this one. Solution. Okay, is it clear? So the algorithm, the Q algorithm, fast in, fast out, it goes like this. So again, see
Sir.
here, Ashlam,
Sir,
left, right. I will go all the path, both path simultaneously. Now we have 4 different options. I will go all 4. Okay, continuously exhausting all the possible resources. Okay, so breadth first search can take more time. There is no fixed winner. It depends on luck. হ্যাঁ বলো, question.
মানে স্যার আমরা ব্রেড ফার্স্ট সার্চ তো স্যার মানে আরো বেশি প্যাথ ইয়ে করতেছে, লাইক আমরা যদি একটা প্যাথ এক্সস্ট করে ফেলি, আমরা যদি এখানে মনে করেন যে মানে সেটা কি
ওই
কমপ্লিটলি
জন্য তো
লাক
বললাম,
ডিপেন্ড?
depends on luck. Depends on luck. DFS can provide you the best one very quickly, but other way, DFS is sure to find the solution, but it might take more time. Okay. আচ্ছা, any question?
স্যার তো ডিএফএস আমাকে স্যার মানে আইদার খুব তাড়াতাড়ি এটা সলিউশন দিবে অর অনেক লেট মানে অনেক দেরি করবে সলিউশন
later
দিতে,
দিবে।
বাট
Yes.
বিএফএস আমাকে এনশিওর করবে যে আমি একটা সলিউশন পাবো একটা অপটিমাল টাইমে।
হ্যাঁ, আমি ডেফিনেটলি সলিউশন পাবো।
বুঝছি।
আচ্ছা, so the question that you have written, LIFO কি path cost এর উপর বেস করে ডিসাইড করবে? See again, no, path cost, I have not even defined the path cost yet. Okay, path cost was something I mentioned earlier. So far we have seen 2 algorithms. Okay, 2 algorithms, one is our BFS and another is our DFS. We have not, in those 2 algorithm, we have not even defined the path cost yet. আচ্ছা, আসতেছি একটু পরে. So these 2 algorithm you see, these are called okay. Now, these algorithms, this is called uninformed search. Uninformed means, you see, these algorithms do not use problem-specific knowledge. It's a problem-specific knowledge. What does it mean? So, for instance, think of like Google Map. Do they use any problem-specific knowledge to find the route? করে কি করে না?
Sir, these queue and
Yes.
stack are uninformed search.
Yes, both of them are uninformed search. Now, my question, Google Map. So, the Google Map, the agent, is it using any problem-specific knowledge when finding the route?
স্যার গাড়ির নাম্বার যে রুট ফাঁকা আছে নাকি এটা দেখার জন্য।
গাড়ির নাম্বার কেন ইউজ করবে বুঝলাম না, বাট ইয়েস,
Number of
it uses the
number of
route information.
cars.
Number of cars, হ্যাঁ, ঠিক আছে। The number of cars, that means the traffic jam. Yes, they uses some problem-specific knowledge. In general, in many problems, real world problems, we usually have some problem-specific knowledge. Okay, and using those problem-specific knowledge, will make our search much more efficient. If we use some problem-specific knowledge, then our search will become more efficient. So when we utilize such problem-specific knowledge, this is called informed search algorithm. Okay, so it is different than uninformed search. You see, when you go for DFS or BFS, we are not using any other information. We are just looking at this. I have one way, I have 2 or 3 different ways. Whatever the way I choose, I will go. There is no other information available to decide which one might be the optimal one. There is no other information available. That's why it is uninformed. This is the simplest one. But if we can use or create some problem-specific knowledge, then the search will become much more efficient. That is what we call informed search algorithm. Okay. So what can be the problem-specific knowledge in our scenario? Okay, সেটা বলতেছি। So informed search algorithms, the informed search algorithm মধ্যে পড়ে আচ্ছা আরেকটা জিনিস বাদ দিছিলাম এখানে। So there are many variation. You see, I have showed you 2 of them. There are many variation of this algorithm. Okay, for instance, there is a variation of called depth limited search. Okay, a variation of DFS. Depth limited search means, you see, we are exhausting one path. So it can happen there are 100 different stages in that path. Let's say আমি আগে X এ চলে গেলাম, X route এ চলে গেলাম. The X route can be very long. Will I keep going and going before coming to the previous one? That will take a lot of resources. So what you can do, you can set up a limit. I will check maximum 10 different states. Okay. From X route, when I go to X route, I'll check maximum 10. If I don't find the solution within these 10 moves, well, I come back to the other one. Okay. So you limit, you carve that path that I will not exhaust the entire path, but I will stop after a certain moment. So that's depth limited search. It actually improves upon the DFS and minimizes one of the major issue of the DFS algorithm. So these are the basic 2 algorithm. There are many variations of it. Okay. So this is one of them. You will find another. You will find some other as well. But still, all of them are uninformed search with some external criteria to improve the performance. আমার কথা শোনা যাচ্ছে clearly? বোঝা যাচ্ছে clearly?
Yes, sir.
Yes, sir.
আচ্ছা। Now for informed search algorithms, one is called greedy search. A greedy algorithm, this is best first. Another one is A-star search. Both of them are very popular. Okay. Now, informed search algorithm is something that is utilized even more. Okay, utilized more often, depending on the problem. Let's see. What can be the greedy search algorithm? So greedy search algorithm uses a heuristic function. Uses a heuristic function. হয়ে গেল।
স্যার আর মাথায় ঢুকতেছে না স্যার।
হ্যাঁ, এটাই শেষ, এই জায়গাটা শেষ করে দিই। আচ্ছা, সো হিউরিস্টিক ফাংশন মিনস, এটা শেষ না করলে তোমার জিনিসটা কমপ্লিট হবে না আর কি, তোমার জিনিসটা কমপ্লিট হওয়া দরকার। আচ্ছা, সো হিউরিস্টিক ফাংশন মিনস সাম ওয়ে টু ইভালুয়েট actions or moves. So you, in the search algorithm, previously we did not have any other way to evaluate the action that, okay, this path is better or that path was better. There is no way to evaluate it. We are just checking. But in greedy algorithm, you put a heuristic function to evaluate some way the cost of that path. আমার কথা বোঝা যাচ্ছে? So that kind of heuristic function is changes everything. And depending on the quality of the heuristic function, well, the search becomes very good or very bad. So let's see. One of the heuristic function that you can use can be, for instance, for previous example, that is a Manhattan distance. Do you know what is a Manhattan distance?
No, sir.
So Manhattan distance is like the block distance. Okay, how many blocks away? So if you use block distance, I will show you the example. Then that distance becomes like from a particular position, how many Manhattan distance away the solution is. আসতেছি সেখানে. Let me give you another example if you go there. Let's say I have this initial position A to B, 5. আচ্ছা. So see, what would happen in DFS? Every algorithm will come to B, okay, A to B. So the total cost, let's say now 5, cost or whatever is. Now the cost is 5 now. From B, I have to make a choice. That's where the AI agent has to decide. If I go DFS, it will either one, it will take, this is the final state. It will take either of the route and exhaust that path. What BFS would do, it will move both at the simultaneously, one after another. Now, when it comes to greedy choice, there has to be associated a heuristic function there. Let's say for here, the heuristic function measures the quality. Now we have some kind of path cost. The idea of path cost comes here. In informed search, I have some kind of cost value. And in uninformed, I don't have any cost. Let's say somehow we have measured this cost. The cost of the path is 6 and 10. So from B, what should be the next move? Based on greedy choice, I should go to C or D?
C.
C.
C. Because from that point of view, you see, it does not know anything below that. It does not know anything below this one. It does not anything. B looks only at C and D. It finds that, okay, the C route has low cost, so I will only go in that direction, C. বোঝা গেছে আমার কথা? So if I move to this one, so my path cost becomes 5, 6, but now I have very large, 15, then 20. So what is the total cost?
A
Total
lot.
cost is very large.
46.
But if we had made the move this way, then we had 5, 10, 10, and 5. This path cost is lower. But you see, when you make this greedy choice, okay, based on this one, is the greedy choice the correct one?
No.
No. So you see, the greedy choice, in greedy algorithm, we call it a greedy choice. Okay. You create a choice. So which moves, greedy choice is like, which move looks more promising from immediate perspective. From your immediate point of view, which move looks the most promising? Based on that one, you take a greedy choice and proceed, and hope that the greedy choice will give you the optimal solution. But it sometimes does, it sometimes doesn't. Okay, so it is not a fix that this is going to give you the best solution, but in general, greedy choice gives you the best solution, like 60% of the time, 70% of the time. What we say, the greedy choice will give you a suboptimal solution. Okay, it may not give you it is likely it is going to give you not the optimal one, but some suboptimal solution. So usually a problem can have, let's say, 10. Out of 10, 2 of them is the worst, 2 of them is the best, and 5 of them are suboptimal, some of them are very low. So the greedy choice is going to put towards one of the suboptimal solution. Okay, আমার কথা বোঝা গেছে? Any
Yes,
question?
sir.
So let me show you the visualization.
গ্রেডি চয়েস কি জাস্ট যে কোনো একটা পাথই নিবে?
Yes, greedy choice হচ্ছে যে কোনো একটা path choose করবে. Whenever there is a way, based on the greedy choice, it is going to choose one path. Okay.
ওইটা তো পুরোটা এক্সস্ট করে ফেলবে।
হ্যাঁ,
গ্রিডি চয়েসে মানে যে পার্টটা চুজ করতেছে ইমিডিয়েট করে, মানে ওটা তো পুরোটা এক্সস্ট করে ফেলতে হবে ওর।
হ্যাঁ, ওটা এক্সস্ট করে ফেলবে, যেটা চুজ করবে সেটা এক্সস্ট করবে। দেখো আমি তোমাকে দেখাচ্ছি এখন, এইটা দেখো তাহলে বুঝবা। আচ্ছা, সো নাও আই হ্যাভ হোয়াট ইজ দ্য হিউরিস্টিক ফাংশন? ম্যানহাটন ডিস্টেন্স।
Sir, one question. Is it possible to not reach our goal using greedy choice?
Yes, it can happen.
Okay.
Greedy choice will not make you, there is not a guarantee that the greedy choice is going to reach the goal.
Okay.
Okay. It is based on the current perspective. From the current perspective, it may not choose the best way. It has to go to the second one next. Acha. Now, Manhattan distance, you see, from the position D and position C, from the position D, from this one, Manhattan distance is 1 block, 2 block, 3 block, 4 block, 5 block, 6 block. The block distance is called the Manhattan distance. It does not take into consideration that this is not a possible path. It just gives you the direct distance. বোঝা যাচ্ছে আমার কথা?
Yes, sir.
It gives you the block distance. So from C, the block distance is very higher. So that's the heuristic function you are using. So from this is the block distance. So if you check this one, 16, 15, 12, from this position, which one, 11 and 13, which, if you apply the heuristic function, which one has the lowest Manhattan distance? Left or right?
11. Right.
11. So I will go in this way. Gelam. এখন again, I have two possible. Which one is the lowest Manhattan distance?
দুটোই সেম।
Both are same. So you can move any other direction. Doesn't matter. Okay. এই পাশে গেলাম, solution নাই. Come back to the previous state. আসলাম এখানে 7, 7. Now I have two distance. Which one I'll move? Two
6
direction. 6 Manhattan distance. 6, 5. Now again, I have two direction. Which one I'll move? The lowest one.
4
এই পাশে গেলাম, solution নাই. I will come back here, then go this way and find the solution. বোঝা গেছে আমার কথা?
আচ্ছা স্যার।
স্যার, এই
হ্যাঁ,
এক্সাম্পল ওয়াইজ তো আমরা সবসময় গ্রিডি চয়েস থেকে সলিউশনে
আমরা
পৌঁছাতে পারবো।
solution পাবো। It is not the optimal solution. Solution পাওয়া যাবে, but not the optimal one. Depending on the scenario, let's say when you go for machine learning, you will find some search problem. When you apply greedy search algorithm, you will not find the optimal solution in many cases. Okay, it depends on the scenario, the task at hand. Okay. Acha. Any question? So you
এখানে
can
যে
see this
নাম্বারটা
was
অ্যাসাইন করা হয়েছে আগের বার, ওটা কি মানে ব্লক মানে যে
Manhattan
বারগুলোতে
distance.
যাওয়া যায় না ওই ব্লক গুলো ধরা হয়েছে, মানে ম্যানহাটন ব্লক?
Yes, block distance. Manhattan distance মানে হচ্ছে কত block distance away আছে ওই পজিশনটা। From here you see path means 1, 2, 3, 4, 5. Distance হচ্ছে 5. It is not going to show you the path distance, it is the block distance. Manhattan distance হচ্ছে block distance বলা হয়। ঠিক আছে? আচ্ছা, আমরা একটু শেষ করি জিনিসটা, অনেকক্ষণ হয়ে গেছে। Any other question?
না
আচ্ছা,
স্যার,
so
আর কোনো
তাহলে
কোশ্চেন
আমরা
নেই।
যদি এখানে আসি। So this is one algorithm, the greedy algorithm. So similarly, greedy algorithm এর মতো আরেকটা অ্যালগরিদম আছে, এটাকে বলা হয় A star search. Okay, A star search. If you check that PDF, you will find the A star search there as well. It does not just use the heuristic function, it also another one, G of n. Okay, cost to reach the path. Okay, this is actually path to goal, distance from path to goal, the Manhattan distance plus it has 2, 1. Okay, so there are two functions joined together in A star search. It uses two functions, just that's the difference. If you check the simulation there, you will find the answer. What is the difference? Very simple, not much different. So these algorithms, like this one and this one, these are called informed search algorithms. So what does informed search do? It uses some additional information. Okay, some information, it can vary depending on the problem, but uses some information to take that decision, which one is a more suitable one. It does not mean that informed search is going to give you the optimal solution, but the chance is now higher. The probability of finding an optimal solution is now better. The efficiency of the algorithm increases. Is it clear? Any question? Any question?
স্যার বেসিক্যালি স্ট্যাক আর কি আমরা ইউজ করতেছি আনইনফর্মড সার্চের জন্য আর ইনফর্ম সার্চের জন্য গ্রিডি সার্চ আর স্টার সার্চ।
হ্যাঁ, গ্রিডি সার্চের জন্য গ্রিডি আর হচ্ছে এ স্টার সার্চ হচ্ছে আমার ইনফর্ম সার্চের জন্য। ঠিক আছে? আচ্ছা, so you have seen, so search problem, what we are discussing today, what we have discussed today, we have seen some search problem. Search problem is we have some solution, finding a maze or whatever. So there can be different ways of finding that solution. আচ্ছা, it can be either, if I define it, it can be either uninformed, informed, or uninformed search. In the uninformed search, you have the BFS1 or the DFS1. In the informed search, you have seen the greedy choice and A star search. Okay. Now, I will provide this PDF as well as one article. You go through that article, you will find some information like what is the difference, what is the pros and cons of that algorithm. I have not been able to say everything. So you definitely should go through that article at least once. একবার পড়লেই বুঝতে পারবা, but definitely go through that article. সবকিছু এখানে define করা হয় না. So you have seen some type of search algorithms today. Okay. In the next class, we will see some other type that's called adversarial search. What is adversarial search? Adversarial search is when it comes to play a game. The possible moves of the game, like a chess game. How an AI agent can play a chess game. We are going to learn that thing. So adversarial search is a little bit different because our traditional, this kind of informed or uninformed search, they are not going to be enough to find a solution, enough to play a game. So it's it's a little bit different approach. That's called adversarial search. You think of it like an adversary. And all of these things that we are saying in terms of the AI agent's perspective, this can be a single agent system or a multi-agent system. So in terms, if I define based on the AI agent, all the algorithms we have seen so far, are they single agent or multi-agent?
Single agent.
Single agent, because
Single
one
agent.
agent is making the decision. One agent is, there is only one agent, he is making the decision always. So everything we have seen so far are single agent system. Later, we'll see some multi-agent systems. Okay. So these are called population-based search algorithm. One, particle swarm optimization. Okay. There are many different types of population-based search algorithm. So we'll see some of them. So that's another type of search where the decision that we're taking, you see in these cases, the decision is taken by one agent. When you have multiple agents, the probability of finding a solution becomes higher. Okay. So when the search space is much more complex, you will need multi-agent system. So we'll gradually go there. Okay. Acha, I think that's up for today. I hope you have some idea of how a single agent system tries to find a solution to the search problem in some search problem. Later, we'll see some other search problems and how solution can be found. How an AI agent can find a solution. Okay. Any question? Karo kono question? Okay.
Sir, will you
If not,
provide us
then
the recording of today's class?
some portion has been recorded, some portion has not been recorded. I will share. Acha, please write your student ID in the chat.